In this video, we will understand Boyer-Murray algorithm. Boyer-Murray algorithm finds the pattern string or the substring in a given main string. So a main string is given. Boyer-Murray algorithm will find out the pattern string or the substring. So what are the steps of Boyer-Murray algorithm? First step is construction of shift table. So how to construct the shift table? As in the case of Horspool algorithm. See, in Horspool algorithm also we constructed shift table. The same method is used for the construction of shift table here also. Second step is construction of D2 table. Anyway, we will discuss this in detail, but this is an important step in Boyer-Murray algorithm. Compare the pattern string in the main string. When the pattern is not found, find the number of right shifts with the help of shift table and the D2 table. See, this is the most important step. We have to find the number of right shifts with the help of shift table that we constructed and the D2 table that we constructed. And steps 3 and 4 are repeated until the pattern is found or the main string is completely explored. I think Boyer-Murray, if you understand the construction of shift table and D2 table and how to calculate the number of right shifts, it is quite straightforward algorithm. Now let us understand the construction of shift table. How to construct the shift table? Let us consider the pattern string as Bangalore. The length of the string is 9. 9 characters are there in Bangalore. And we are considering 27 characters. That is capital A to capital Z plus one blank character. So A to Z is 26 character plus one blank character, that is 27 characters. Initially, we give the value 9 to all the 27 characters. That's how it is. Now just observe how to construct the shift table for Bangalore. In front of B, the first character, just count how many characters are there. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, change B to 8. Next character is A. Just count how many characters are there in front of A. 1, 2, 3, 4, 5, 6, 7. Therefore, A should become 7. The third character is N. Just count how many characters are there in front of N. 1, 2, 3, 4, 5, 6. So, N will become 6. Similarly, the fourth character is G. How many characters are there in front of G? 1, 2, 3, 4, 5. Therefore, G will become 5. Next character is A. Count how many characters are there in front of A. 1, 2, 3, 4. See, earlier for A it was 7. Now it will become 4. Next, L. Just count how many characters are there in front of L. 1, 2, 3. Therefore, for L it will become 3. Next character is O. Just count how many characters are there in front of O. 1, 2. Therefore, for O it is 2. Next character is R. Count how many characters are there in front of R. Only 1. Therefore, R gets a value 1. Last character you need not have to do anything. So now, the shift table for the pattern string Bangalore. See the shift table value. So what is the value for B? 8. What is the value for A? 4. What is the value for N? 6. What is the value for G? 5. L 3. O 2. R 1. E, anyway we did not do anything, therefore it is 9. And star means for all the other characters it is 9. So this is the shift table value for the pattern string Bangalore. Let us consider one more example. Let us take the pattern string as Kannada. The length of the string is 7 and we consider this 27 character, meaning capital A to capital Z plus one blank character. So all of them are initially initialized to 7. Now, the first character is K. Count how many characters are there in front of K. 1, 2, 3, 4, 5, 6. Therefore, K will become 6. Next character is A. Count how many characters are there in front of A. 1, 2, 3, 4, 5. Therefore, A will become 5. N, the third character. How many characters are there in front of N? 1, 2, 3, 4. So N will become 4. Fourth character is also N. Count how many characters are there in front of N? 1, 2, 3. Therefore, now N will become 3. Next character is A. How many characters are there in front of A? 1, 2. So already A was 5. Now it is updated to 2. D. There is only one character in front of D. Therefore, D will become 1. Last character, we need not have to do anything. Therefore, the shift table for the pattern string Kannada is, so what is the shift table value for K6, A2, N3, D1, and for all the remaining characters, it is 7. I think construction of shift table is quite easy. Now, straight away we'll go to the algorithm. P stores the pattern. Array P stores the pattern. Length of the pattern is M, and the pattern is stored in P from 0 to M minus 1. Simple. And ST is our shift table. Its size is 0 to A size minus 1. And A size is the alphabet size. And alphabet size, it can be 256 if you consider all the ASCII characters. It is only 26 if you consider A to Z. In our example, it was 27 because we considered A to Z plus one blank character. And similarly, A size is 62 if you consider capital A to capital Z, small a to small z, and 0 to 9. Now, the input string is the pattern string P, and the output is the shift table ST. So this is the algorithm. So 0 to A size minus 1, meaning for all the characters, we initialize the length of the pattern string. This loop will initialize M, which is the length of the pattern for all the characters in the shift table. And we know shift table will have A size characters. Already we have seen this example. Now, for J is equal to 0 to M minus 2, index is equal to ASCII value of P of J minus ASCII value of A. ST of index is equal to M minus 1 minus J. See, this loop will find the shift table for all the M minus 1 characters in the pattern, because last character we need not have to worry. Therefore, for all the M minus 1 characters in the pattern, we have to find the shift value. In the bracket, it is also written. We know the last character in the pattern will not have a shift value. Yes. That's all the algorithm. And also the other thing is, please refer to my video Horspool algorithm for detailed explanation of this shift table algorithm, because there I have shown with some values, real-time values and all. So you can refer to that particular video. Now let us understand the construction of D2 table. So construction of D2 table. First of all, we should understand the meaning of suffix and prefix. What is suffix? Suffix of a string means the last part of the string. That is, let us consider the string college. What are the suffixes for this string college? E, G, EG, LEG, LLEG, and OLLEGE. Length of the string college is 7. There are 6 suffixes. Similarly, prefix of a string means the first part of the string. The prefixes for the string college are, you can just observe the prefix now, C, CO, COL, COLL, COLLE, COLLEG. So the length of the string college is 7, but the prefixes are 6. In general, if the length of the string is n, the number of suffixes will be n minus 1. Number of prefixes also will be n minus 1. Now, let us consider a string needle. So how many suffixes or prefixes are possible? 5, because the length of needle is 6. Therefore, k is equal to 1 to 5, meaning k is equal to 1 means the prefix or suffix size is 1, 2, 3, 4, 5, like that. We do this. Now, initially D2 value, we assume it as 0, initialized to 0. Carefully understand step 1. Search for the same pattern of length k as a suffix. So whatever suffix you are taking, that suffix you have to search in the string. Length should be the same. Pattern and the suffix length should be the same. In the middle of the substring, starting from the right, in the middle, and middle means not the prefix. Middle of the string means it should not be the prefix. Okay. Another condition is there. It should have a different preceding character. So whatever suffix is there, whatever pattern is there, the preceding character of both suffix and pattern should be different. I think with some examples it will be more clear. Now, when that is the case, the number of what is D2 value? The number of characters in front of the found pattern. I think with some examples it will be more clear. Here, we will consider E here. From the right, you have to search for E, where it is found from the right. Right means Urdu style. Okay, from the right, you have to search for E. Yes, E is found here. Okay, very good. Now check the preceding characters. Yes, preceding characters are different. So therefore, you count the number of characters in front of the matched pattern. That is 1, 2, 3. So this will be the count. So 3. Very good. Next, we will consider LE. LE, is it found from the right? The pattern, the suffix LE. No, LE is not found. Therefore, we cannot do anything. Go to the next. K is equal to 3 means size is 3 of the suffix. So DLE, is it found anywhere in the middle? No. Don't do anything. Similarly, EDLE? No. Similarly, EEDLE? No. Don't do anything. So I think this is one string. We'll consider one more string. AA, BB, AB. And the length is 6. Therefore, we are considering K from 1 to 5. And D2 value should be initialized to 0. Yes, it is initialized to 0. First, we will consider B. Now, B should be searched from the right, Urdu style. Just see. Yes, first B is found here. Check the preceding characters. Yes, they are different. So, when they are different, you can count the number of characters in front of the matched pattern. That is 1, 2. So, this will be the value. Very good. Next, K is equal to 2. So we should consider length to AB. Search AB from the right, Urdu style. Just observe, AB is found here. Now check the preceding characters. Yes, preceding characters are different. Therefore, count the number of characters. 1, 2, 3. So initialize it to 3. Yes. Now BAB. Check whether BAB is found in the middle. No, BAB is not found. Don't do anything. BBAB, not found, don't do anything. Again, this suffix, no, don't, not found, therefore don't do anything. Now, one more string we will take, LETELE, and the length is 6, therefore we have taken K value from 1 to 5. Initialize it to 0, D2 value should be initialized to 0, yes. First, K is equal to 1, length 1 suffix. E, search for E from right. Where is E found? Just observe. Yes, E is found here. When it is found, check the preceding characters. They are different. Very good, they are different. Therefore, count the number of characters in front. 1, 2, initialize it to 2. Very good. Next, LE. Is it found in the middle? It is found in the prefix, but it is not prefix. We don't want in the prefix. We want only in the middle. Carefully understand, middle of the string means it should not be prefix. Very, very important. LE is found in the prefix. We want it in the middle. Therefore, it is not found. Therefore, go to the next. ELE, is it found in the middle? No. TLE, no. This string also, no. So, we have done step 1 for all the 3 strings. Now, step 2. Step 2, carefully understand step 2. If D2 of K is equal to 0, to the following. And in needle also, 4 values are, D2 values are 0. In AA, BB, AB also, 3 values are 0. In LE, TE, LE also, 4 values are 0, D2 values. So whenever D2 value is equal to 0, do the following. This is step 2. After step 1, then we have to apply step 2. What we have to do? Carefully understand the English. If the complete suffix or the last part of the suffix, see, this is important. If the complete suffix or the last part of the suffix is found in the prefix of the substring, See, complete suffix or the last part of the suffix is found in the prefix of the string. Then D2 will be the number of characters in front of the matched prefix pattern. It is not middle of the string, it is prefix. Otherwise, D2 should be initialized to the length of the string. Let us go to needle. Just see LE. LE, is it found in the LE or E? Last part of the suffix. See, complete suffix is LE. Last part of the suffix is E. LE or E, is it found as the prefix of the substring? No. Therefore, don't do. You initialize to the length of the string. D2 is initialized to the length of the string. Good. DLE. DLE or LE or E, is it found as the prefix of the string? No. Therefore, it should be initialized to the length of the string. What is the length of the string? 6. Yes. Similarly, EDLE. EDLE or DLE or LE or E, is it found as the prefix of the string? No. Therefore, it should be initialized to the length of the string. Similarly, here also it is initialized to the length of the string. So now we have D2 values for needle for all the cases. K is equal to 1 to 5. Next, we will come to AA, BB, AB. Yes, 0 is there. BAB, K is equal to 3. Therefore, we have to consider BAB. BAB, either BAB or AB or B, is it found as the prefix? No. Therefore, it should be the length. Therefore, 6. Similarly, BBAB. BBAB or BAB or AB or B, is it found as the prefix? No. Therefore, 6. Similarly, here also it is not found. Therefore, it is 6. So, we have the D2 values for the pattern AA, BB, AB. Yes. Next, we will go to LE, LE. So 4 zeros are there. First we will take K is equal to 2. Therefore LE. Now LE or E, is it found as the prefix of the string? Yes. LE only is found as the prefix. So very good. First time we are getting the prefix. LE only is found as the prefix. Therefore count the number of characters in front. 1, 2, 3, 4. Therefore D2 value will be 4. Very good. Next K is equal to 3. ELE. Now ELE or LE or E, is it found as the prefix? LE is found as the prefix. Very good. Meaning last part of the suffix is found in the prefix. Very good. Count the number of characters. 1, 2, 3, 4. Yes, we get 4. Next K is equal to 4. Therefore TELE. TELE or ELE or LE or E, is it found as the prefix? Yes. Last part of the suffix LE is found as the prefix. Therefore, count the number of characters. 1, 2, 3, 4, 4. Very good. Last one is ETELE. ETELE, TELE, ELE, LE or E. Is it found as the prefix? Yes. Last part of the suffix LE is found as the prefix. Therefore, count the number of characters in front. 1, 2, 3, 4, 4. I think these two steps are very important. This is an important component of Boyer-Moray. First, you apply step number 1. Then you apply step number 2. In step number 1, whatever D2 value you have decided, don't disturb that. In step number 2, you should consider only those patterns for which D2 value is equal to 0. That is the condition. D2 of K is equal to 0. Do the following. Yes, I think these two steps, one after the other, you should apply to construct the D2 table. Now, the same algorithm, K is equal to 1 to M minus 1, D2 of K is equal to 0. First initializing to 0. Then, if there is same pattern, has suffix in the middle of the pattern, not prefix, with a different preceding character, then D2 of K is equal to number of characters in front of the found pattern. Just now we did this. This is step number 1. Step number 2, for K is equal to 1 to M minus 1. If D2 K is equal to 0, then only do the following. What is that? If the complete suffix or the last part of the suffix is found in the prefix of the substring, then D2 of K is equal to number of characters in front of the matched prefix pattern, not matched pattern, matched prefix pattern. Otherwise, it is length of the substring. I think this algorithm is also construction of D2 algorithm. Step 1 and step 2. I think it should be quite easy. Little confusing, but don't get confused. It should be quite easy. And construction of D2 table is very here. Let us do both construction of shift table and D2 table together. Let us consider the string Kannada, shift table value, and this is D2. So for K, what is the shift table value? How many characters are there in front of K? 6. For A, 5. For third character N, 4. For fourth character N, 3. It should be updated to 3. Again for A should be updated to 2. D is 1. Last, we did not have to do anything. For all the remaining, the length of Kannada is 7. Therefore, it should be 7. Therefore, the shift table is complete for Kannada. Let us build the D2 table. And D2 should be initialized to 0. Yes. First, let us consider K is equal to 1. Therefore, the suffix size is A. Search for A from right. Carefully observe. Yes, it is found. Check the preceding characters. They are different. Therefore, count the number of characters in front. 1, 2, 2. Very good. Next, DA. DA, is it found in the middle? No. Don't do anything. ADA, no. NADA, no. LNADA, no. And this string also, no. Now, step 2. DA. DA or A, is it found as the prefix? No. Therefore, it should be initialized to the length, which is 7. Similarly, ADA, DA or A, is it found in the prefix? No. Therefore, length. Similarly, NADA, ADA, DA or A, is it found in the prefix? No. 7. Here also it will become the length of the string. Here also it will become the length of the string. Now for the string Kannada, we have the shift table also and we have the D2 table also. Let us take one more example, Rajkumar. So now the shift table value, D2 table. First let us fill the shift table value R. 7 characters are there in front, therefore it is 7. For A, it is 6 because in front you have 6 characters. For J, it is 5. For K, it is 4. And for U, it is 3. And for M, it is 2. And again for A, it is 1. So A is updated to 1. For all the remaining, it is 8 because the length of Rajkumar is 8. So we are ready with the shift table value for the string Rajkumar. Now D2 values. D2 value should be initialized to 0. Yes. Next, K is equal to 1. Suffix length is R. Search R from right in the middle of the string. Now carefully understand, R may be found as prefix. No, we are not interested in prefix. We are interested only in middle. So do we have any string R in the middle? No. So we can't do anything. AR in the middle? No. MAR? No. This also no. So step 1 is over. Next to step 2. R. Is it found as the prefix? Yes, R is found as the prefix. Therefore, find the number of characters in front. 1, 2, 3, 4, 5, 6, 7. Therefore, it should be initialized to 7. Very good. Now, AR. Either AR or R. Is it found as the prefix? Yes, R is found as the prefix. Therefore, count the number of characters. 1, 2, 3, 4, 5, 6, 7, 7. Again, MAR or AR or R. Is it found as the prefix? Yes, R is found as the prefix. Count the number of characters in front. 7. Again, UMAR. Either UMAR, MAR, AR or R. Is it found as the prefix? Yes, R is found as a prefix. 1, 2, 3, 4, 5, 6, 7. 7. Similarly, here also R is found as the prefix. 1, 2, 3, 4, 5, 6, 7. In this string also, R is found as a prefix, therefore 1, 2, 3, 4, 7. In the last string also, R is found as the... Yes. Now, for Rajkumar, we have the shift table values and we have the D2 values also. Let us consider one more string. BB, AB, AAA, BA. Shift value, only 2 characters AB, and this is the D2 value. First, let us fill the shift value. For B, what is the first one? 8 because 8 characters are there in front. Again, second character is B. Now it is 7. For A, it is 6. Again, for B, it should be updated to 5. Again, for A, it is updated to 4. Again, it is updated to 3. Again, it is updated to 2. And last but one character B, it is updated to 1. And for all the remaining characters, it is 9 because the length of the string BB, AB, AA, ABA is 9. So shift table values are done for the string D2 values. D2 should be initialized to 0. Yes, it is initialized to 0. Now, step 1. A. Search for A from right. Carefully observe. A is found here. Check the preceding characters. Yes, they are different. Very good. When they are different, we are happy. 1, 2. Yes. Now, BA. Search for the string BA from the right. Carefully observe. BA, BA, BA. Yes, it is found. Check the preceding characters. They are same. See, we cannot consider this because the preceding characters are same. I think first time we are coming across this situation. Preceding characters should be different. Unfortunate, we cannot do anything. Again, search for BA from the right, move towards. Again, one more BA is found. Check the preceding character. Yes, B and A. Now, the preceding characters are different, therefore we can count. 1, 2, 3, 4, 5, 6. 6. Very good. Next, ABA. Search for ABA from the right. Yes, it is found. Check the preceding characters. They are different. Therefore, 1, 2, 3, 4. Yes. AABA. No, it is not found. This also is not found. Not found. Not found. Not found. So step 1 is over. Now let us come to step 2. AABA. Either AABA or ABA or BA or A. Is it found as a prefix? No. Therefore, it should be the length of the string. Therefore, it is 9. Here also it will become 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 9. Now, we have constructed both shift table value and D2 value for a given pattern string. This is important. Any given problem, we should create both shift table as well as the D2 table. Now we know how to construct the shift table, how to construct the D2 table. Now we should know how to find out the number of right shifts. This is very, very important. So how to find out the number of right shifts? When the pattern is not found, because when the pattern is not found, then only we move to the right. But how to find out the number of right shifts? Step 1, find the number of matched comparisons K. How to do that? I think we will illustrate with some examples. Suppose if it is Kannada and this thing is ABCD, D and A are matched. No, they are not matched. Therefore, there are no matched comparisons. Therefore, K is equal to 0. See, there were no matched comparisons at all. D and A were compared. They were not matching. Therefore, K is equal to 0. Here you take A and A. A and A matched, but B and D did not match. So how many matched comparisons we had? 1. Therefore, K is equal to 1. Now we will take this example. A and A matched, D and D matched, B and A did not match. Then how many matched comparisons we had? 2 matched comparisons. Therefore, K is equal to 2. See, very important. What is K? K is the number of matched comparisons. Make it very clear because K value becomes very important. Okay, very simple. K value is the number of matched comparisons. Find the number of right shifts. Let us consider D as the number of right shifts. So what is D? D is the number of right shifts that we have to do when the pattern is not found. There are 2 cases. Case 1, when K is equal to 0, meaning when there are no matched comparisons, K becomes 0. In this case, what you do is D is the shiftable value of the mismatched character in the main string. Very simple. So what is D? You take the shiftable value of what character? Of the mismatched character in the main string. Simple. Case 2, when K is greater than 0, meaning when there were matched comparisons. When K is greater than 0, how to find out the D value? That is D1. We calculate this as D1. D1 is equal to maximum of shift table value of the mismatched characters in the main string minus k and 1. Carefully understand, whenever k is greater than 0, we have to first find out the D1 value. What is D1 value? Maximum among two values. What is the first value? Shift table value of the mismatched characters in the main string minus k. K means the number of matched comparisons and 1. And also we have D2 value. What is this D2 value? D2 value should be taken from the D2 table for the given k. Therefore, D2 is equal to D2 value from the D2 table for the given k. And last, what is D? D is equal to maximum of these two, D1 and D2. Whatever value is maximum among D1 and D2, that should be taken as D. This is in case of case 2. Now, D will denote the number of right shifts. See, carefully understand, we should find out the number of right shifts. There are two cases, k is equal to 0, k is greater than 0. In both the cases, we know how to find out the number of right shifts. And also carefully understand, when we are finding the number of right shifts, we use the values of shift table also, we use the values of D2 table also. I think this should be quite simple, quite straightforward. Let us consider some examples of pattern matching. First example, let us consider the pattern as AABA. First we will do the shift table and also D2 table. For AABA, shift table value for A, 3. Second character is also A, therefore it should be operated to 2. For B, it is 1. For all the remaining characters, it is 4. So our shift table is ready. Let us do our D2 table also. Step 1, it is initialized to 0. Step 1, A, find A, yes. Check the preceding character, they are different. Therefore, 1, 2, 2. Next, K is equal to 2, BA. Is it found? No, it is not found. No need to do anything. ABA, it is not found. Step 1 is over. Step 2, BA. Either BA or A, is it found as the prefix? Yes. A is found as a prefix. Therefore, 1, 2, 3, 3. ABA. Either ABA, BA or A, is it found as a prefix? Yes. A is found as a prefix. Therefore, 1, 2, 3, 3. Yes. So now our D2 table is also ready. This is our main string and this is our substring for which we created the shift table value and the D2 value. Let us do the matching now. A and A are matching, very good. B and B are matching, very good. Or A and D are not matching. So how many matched comparisons? Since there are two matched comparisons, K is equal to 2. And what is the mismatched character in the main string? D. Therefore, you have to take the shift value for the character D. What is the shift value for the character D? 4. Yes. Now, we have to find out D1. What is D1? Maximum of 4 minus 2. That is the shift value of D minus K. That is 4 minus 2 and 1. So this is 2, 1. This is 2. D2. So here K is equal to 2. Just observe, for K is equal to 2, what is the D2 value? 3. Therefore, you have to take 3 here. Now D is maximum of D1, D2. That is maximum of 2 and 3, which is nothing but 3. So when D is 3, the number of right shifts should be equal to 3. Therefore, since D is equal to 3, first right shift is by 3 positions. So let us do the right shift. Yes, by 3 positions it is shifted. Very good. Now let us do the matching from right. A and A matching. B and C are not matching. So how many matched comparisons? 1. And also, what is the mismatched character in the main string? C. What is the shift table value for C? 4. Now, we have to find out D1. That is 4 minus 1, comma 1. That is 3, comma 1 is equal to maximum of 3 and 1 is 3. D2. Now, K is equal to 1 because matched comparison is 1. Therefore, K is equal to 1. Just observe, for K is equal to 1, what is the D2 value? 2. Therefore, our D2 is 2. So what is maximum of 3 and 2? 3. Therefore, the second right shift is by 3 positions. 1, 2, 3. Yes. Yes. Now we match again. A and A are matching. Very good. B and D are not matching. So how many matched comparisons? 1. There is one matching comparison. Therefore, K is equal to 1. What is the shiftable value for the mismatched character in the main string D? That is 4. Therefore, we have D1 is equal to 4 minus 1 and 1. That is 3 and 1, 3. D2. What is the D2 value for K is equal to 1? Just observe the D2 table. 2. That is 2. Maximum of 3 and 2 is 3. Since D is equal to 3, third right shift is by 3 positions. So now 1, 2, 3. Yes. We shifted by 3. Yes. Now let us match. A and A is matching. B and B matching. A and A matching. And yes, we have got the pattern. At what position? At position 9. Now the pattern is found in the main string at position 9. How many shifts happen? Number of right shifts required is 3. Very good. So using Boyer-Moray, we found the pattern in the main string, and the pattern is found in the main string at position 9, and number of right shifts required was 3. Simple example. Let us consider one more example. Let us consider the pattern as AA, BB, AA. First, we shall consider the shift table value. So, and D2 table also we have to construct. For A, it is 1, 2, 3, 4, 5. It will be updated to 4. B, it is 3, updated to 2 again. Again, A is updated to 1. For all the remaining characters, it is 6. You know how to construct the shift table. D2 table, step number 1, initialize to 0. A is found immediate. Find out the preceding characters, they are different. Therefore, 1, 1. AA, it is not found in the middle. BAA not found in the middle. This also not found. This also. Step 1 is over. Step 2. AA, is it found as the prefix? Yes, it is found completely as the prefix. Therefore, 1, 2, 3, 4, 4. BAA, no. The last part of the suffix AA is found. Therefore, it is 1, 2, 3, 4. Yes, 1, 2, 3, 4. Again, BBAA, last part of the suffix is found. 1, 2, 3, 4. Again, last part of the suffix is found. 1, 2, 3, 4. So now we have constructed the D2 table also. This is our main string. This is our pattern string for which we constructed the shift table value and the D2 value. Let us do the comparisons from the right. A and A matching, A and C not matching. So there is only one matching comparison. K is equal to 1. And what is the shift value for the mismatched character C? It is 6. Yes. Now D1 we have to calculate maximum of 6 minus 1, 1. That is 5, 1, 5. D2, K is equal to 1. Just observe, it is 1. Therefore, D2 is 1. So D is maximum of D1 and D2. That is 5 and 1, 5. Since D is equal to 5, the first right shift is by 5 positions. So we have to shift by 5. 1, 2, 3, 4, 5. Yes, the pattern is shifted by 5. Yes. Again, we do the comparison. A and C are matched. No, they are not matching. See, in this particular case, K becomes 0 because there are no matching comparisons. Therefore, K is equal to 0. When K is equal to 0, the shift table value for the character C is 6. Therefore, we have to do the 6 right shifts. D is because here there is no choice at all. D1, D2 will not come at all because the number of comparisons are 0. Matching comparisons are 0. Therefore, the shift table value for the character C is the number of right shift. Therefore, D is equal to 6. Second right shift is by 6 positions. 2, 3, 4, 5, 6. Yes, the pattern is shifted. Now let us do the matching. A matching, A matching, BB matching, BB matching, again A matching, again A matching. Yes, the pattern is found in the main string. At what position? At position 11. And how many shifts were required? Only 2 shifts were required in this particular case. So in this example, the pattern was found in the main string at position 11 when the array starts from 0, and the number of shifts required was only 2. Let us consider example number 3. This is our pattern string. First, let us consider the shift table and also the D2 table. Shift table B, 1, 2, 3, 4, 5, 6. For C, it is 5. Again, for D, it is 4. B, it is updated to 3. For A, it is 2. For C, it is updated to 1. And for all the remaining characters, it is 7. All of you know how to do the shift table construction. Simple. Let us do D2 table. Step number 1. It is initialized to 0. D. Check for D from the right. Yes, D is there. Check the preceding characters. The preceding characters are not same. They are not different. They are same. When the preceding characters are same, we cannot do anything. Therefore, we leave it like that. Next, CD. Is it found from the right? Yes. Check the preceding characters. Preceding characters are different. Very good. 1, 2, 3, 4. So this is 4. ACD is not found. This is not found. This is not found. This is not found. So step 1 is over. Next, we will go to step 2. D. Is it found as the prefix? No. Therefore, it is initialized to length 7. ACD, no, it is not found in initialized to, it is 7. Again, for this also it becomes 7. For this also it becomes 7. For this also it becomes 7. So we have constructed the D2 table also. So shift table is ready, D2 table is ready, and this is our main string. Let us do the comparison. D and D are compared. No matching, therefore K is equal to 0. What is the shift table value for the mismatched character in the main string E? It is 7. Therefore, directly we should shift by 7. So therefore, the first right shift is by 7 positions. 1, 2, 3, 4, 5, 6, 7. Yes, the string is moved to the right by 7. Yes. Now again, we shall start the comparison from the right. D and D matching, C and C matching, A and B no matching. So how many matching comparisons are there? 2. What is the shift table value of the mismatched character B in the main string? It is 3. Therefore, we have to find out D1. D1 is maximum of 3 minus 2 and 1. That is 1 and 1. 1. D2, K is equal to 2. What is the value? Just observe. It is 4. Therefore, 4. So what is the maximum of 1 and 4? 4. Therefore, second right shift is by 4 positions. So we have to shift by 4 positions. 1, 2, 3, 4. Yes. It is shifted by 4 positions. Again, let us do the matching. D and C, no matching. Therefore, K is equal to 0. The shift table value for C, the mismatched character in the main string is 1. Therefore, we have to shift by 1. Yes, 1. So, this pattern is shifted by 1. Again, we have to do the matching. D and D matching, C and D, C and C matching, A and B, no, they are not matching. So now, 2 matching comparisons, K is equal to 2. What is the shift table value of the mismatched character B? It is 3. Therefore, calculate D1. D1 is 3 minus 2 and 1. It is 1 maximum. D2. 2 characters are matching. Therefore, K is equal to 2. Just observe the D2 table. It is 4. So, D2 is 4. Maximum of 1 and 4 is 4. So, D is equal to 4. Therefore, the fourth right shift is by 4 positions. 1, 2, 3, 4. Yes, it is by 4 positions we have shifted. Now, let us do the matching from the right. D and D matches, C and C matches, A and A matches, B and B matches, D and D matches, C and C also will match, and last B and B also will match. So we have found the pattern in the main string at position 16. And how many right shifts we required? We required only 4 right shifts. I think this example is also quite simple, straightforward. Let us consider example number 4. So this is our main string, this is our substring, pattern string. First, we have to construct the shift table and also D2 table. Yes, for A it is 5, for B it is 4. Again for A it is updated to 3. C it is 2. Again for A it is updated to 1. For all other characters it is 6. So our shift table is ready. D2 table initialized to 0 first. Then step number 1, B. Is it found? Yes. What are the preceding characters? They are same. Therefore, we can't do anything. Next, AB. Is it found? It is found as prefix, but we want it in the middle. We can't do anything. Is it found? No. It is found? No, it is found. So step 1, we could not find any D2 values. Step 2, let us see. B. Is it found in the prefix? No. Therefore, it is length of the string, that is 6. This also, yes, AB is found as the prefix of the pattern. That is 1, 2, 3, 4. Similarly, CAB, last part of the suffix AB is found as the prefix. So 1, 2, 3, 4. Similarly, ACAB, last part of the suffix is found in the prefix. That is AB, 1, 2, 3, 4. Same thing here also. So we are ready with our D2 table and also shift table. Now we should consider the pattern matching. So B and A are compared. They are not matching. Therefore, no matching comparisons. K is equal to 0. So when K is equal to 0, what is the shift table value for the mismatched character in the main string A? 1. So it is very simple. Since B is equal to 1, first right shift is by 1 position. Yes, 1. It is shifted to the right by 1. Now again, let us do the comparison from the right. B and B matching, A and A matching, C and A mismatch. So there are 2 matching comparisons. K is equal to 2. The shift table value for the character A is 1. So now let us do D1. What is D1? Maximum of 1 minus 2 and 1. Minus 1, 1. It is 1. So what is D2? K is equal to 2. Therefore, D2 value in the table is 4. So what is the maximum of 1 and 4? 4. Therefore, since D is equal to 4, second right shift is by 4 positions. 1, 2, 3, 4. Yes. It is by 4 positions. Now again, let us do the matching. From the right, B and A, no mismatch. So what is the K value? 0. And what is the shiftable value for the mismatched character in the main string A? That is 1. So we should shift by 1. Third shift, right shift is by 1 position. Yes, 1. Again, B and B are compared, matching. A and A are compared, matching. C and C are compared, matching. A and D, mismatch. So what is the value of K? K is equal to 3. What is the value of D? It is 6. So now let us do D1. Maximum of 6 minus 3 and 1. That is 3 and 1, 3. D2, for K is equal to 3. What is the D2 value? 4. So maximum of 3 and 4 is 4. So number of right shift is by 4. 1, 2, 3, 4. Yes, we shift by 4. Now B and B matching, A and A matching, C and C matching, A and A matching, B and B matching, again A and A matching, meaning we have found the pattern in the main string. At what position? At position 10. How many shifts we had? We required 4 right shifts. I think example number 4 is also quite simple. Let us consider example 5. This is our main string and this is our pattern string. First shift table and also D2 table. Shift table value, just observe, for B it is 8, again updated to 7, for A it is 6, for B updated again, for A updated, updated again, for B last update 1. For all the remaining characters it is 9. So you know how to construct the shift table. For D2 initialize to 0, step 1 A, is it found? Yes. Preceding characters different. Therefore 1, 2, 2, yes. BA, is it found? Yes. Preceding characters are same. They should be different, but they are same. We can't do anything. Again, right? Yes, it is found. Check the preceding characters. They are different. Now we can consider 1, 2, 3, 4, 5, 6, 6. ABA, is it found? Yes, it is found. Preceding characters are different. Therefore, 1, 2, 3, 4, 4. AA, BA, no. This also no. This no. This no. This no. So first step is over. Now second step. AA, BA. So suffix are part of suffix, last part of suffix. Is it found in the prefix? No. Therefore, it is the length of the string 9. For this also it is 9. For this also it is 9. Here also it is 9. Here also it is 9. So you know how to construct shift table and D2 table. Now let us do the comparisons. A and A are compared matching. B and B matching. A and C mismatch. Therefore, 2 matching comparisons. Therefore, K is equal to 2. The shift table value for C is 9. Now, we'll find out D1 value. D1 is equal to 9 minus 2 and 1. That is 7. D2, K is equal to 2. Just observe the D2 table. It is 6. So, maximum of 7 and 6 is 7. Therefore, D is equal to 7. Therefore, the first right shift is by 7 positions. 1, 2, 3, 4, 5, 6, 7. Yes, it is shifted by 7. Very good. Now let us again do the comparison. From the right, A matching, BB matching, AA matching, AD mismatch. So K is equal to 3 and the shiftable value for D is 9. Again, D1, 9 minus 3 and 1. So it is 6. And D2 is K is equal to 3. Just observe the D2 table, it is 4. So 4, maximum of 6 and 4 is 6. Therefore, D is equal to 6. Second right shift is by 6 positions. 1, 2, 3, 4, 5, 6. Yes, it is shifted to the right by 6 positions. Again, let us do the comparison. A and A matching, B and A mismatch. Therefore, K is equal to 1. Shiftable value for A is 2. So D1 is equal to 2 minus 1 and 1. That is 1. D2 for K is equal to 1 is 2. So it is 2. So now D is equal to maximum of 1 and 2, that is 2. So third shift is by 2 positions. Yes. Now again comparison, A and B mismatch. A and B is mismatch. There are no matching comparisons at all. Shiftable value for B is 1. Therefore, fourth shift is by 1 position. Yes. Simple. Again, let us do the matching. A and A matching, B and B matching, A and A matching. Yes, we have found the pattern string in the main string at position 16. And how many shifts we require? We require 4 shifts. I think this example is also quite simple. Now let us consider the Boyer-Moray algorithm. So this is I is equal to m minus 1 and till the end of the string. So this is checking whether the pattern and the main string is matching from the right. If it is matching, we go on incrementing the value of K. And if K is equal to M, we have got the pattern, therefore written I minus M plus 1. If K is equal to 0, meaning no matched characters, then D value is shift table value of the mismatched character in the main string. Therefore, it should be shifted by D. Therefore, I is equal to I plus D. Otherwise, P is equal to shiftable value of the mismatched character in the main string. And you know this, D1 is equal to maximum of P minus K and 1. D2 is D2 value from D2 table for the given K. D is maximum of D1, D2, and I should be moved by D, meaning I is equal to I plus D. That's all. The algorithm Moyer. What is Boyer-Moyer? Boyer-Moray. The algorithm name is given as Moyer, but this is Boyer-Moray algorithm. I think it is quite simple. K is equal to 0. Otherwise, what we should do? That's all. Let us consider the C program for Boyer-Moray. This is the shift table function. Already we have discussed this. If you want detailed understanding of shift table function, please refer to Horsepool algorithm video. And this is construction of D2 table, step number 1. So step number 1 is over. This is the function for D2, step 2. Step 2 of construction of D2 table. Yes. So we have written the functions for construction of shift table and also construction of D2. That is D2 step 1, D2 step 2. Now, Boyer-Moray directly. Anyway, I is less than or equal to m minus 1. So K is implemented if there is matching. If K is equal to M, we have found the pattern, therefore return. Otherwise, if K is equal to 0, you have to return P is equal to STF. This shift table value, I is equal to I plus P. Otherwise, you have to find out D1, D2. D1 is this, D2 is this, and maximum of D1, D2, I is equal to I plus maximum of D1, D2. That's all. Boyer-Moray function, quite simple, quite straightforward. Now the main program. Main program, enter the main string, read the main string, enter the pattern string, read the pattern string. N is the length of the main string, M is the length of the pattern string. First call shift table to construct the shift table. Then call D2 step 1 to perform step 1 of the construction of a D2 table. D2 step 2, you call this function to do the step 2 of D2 table construction. Now we are ready with our D2 table and shift table. Now you call the Moyer function. If position is equal to -1, the pattern string is not found. Otherwise, the pattern string is found at that particular position, and also number of shifts is equal to NOS. That's all the main function for Boyer-Moray. I think the Boyer-Moray algorithm looks complicated, but actually it is very easy. Only thing is you should know how to construct shift table, how to construct D2 table. Apart from that, I think Boyer-Moray algorithm is quite simple, quite straightforward.